Hi everyone, welcome to AWS Security Best Practices for Builders. I am Miles Hosford, the Principal Security Architect for Asia Pacific. In this session, we will explore how builders like you can implement the most common AWS security best practices that allow you to be agile and innovative at the same time as maintaining a high security posture. In this session, we are going to explore the 5 most common domains of security. This includes identity, login and monitoring, infrastructure security, data protection, and incident response. We will examine the top 3 best practices in each domain, giving you a total of 15 best practices to review as we go. Hopefully, many of you will already have implemented these best practices, so this will be useful review material. For those of you that are new to AWS, don't worry. These best practices are easy to follow and even easier to implement. So let's get started. Historically, security has been seen as a technology department that slows builders like you down. The approach has often been overburdensome, complicated, or time-consuming. There is nothing worse for a development team to have a bunch of security requirements dropped on them last minute before production deployment. Sounds familiar? Well, this leads to the saying, move fast or stay secure. You have to choose one or the other. What we want for builders is not to have to make that choice, but to have both. We want you to move fast, innovate, be agile, and at the same time be secure. You can do this through cloud-native security features, but also leveraging unique properties of the cloud, like unprecedented visibility and real-time automation to build a security posture far greater than on-premise deployments. I have already mentioned that we will be focusing on 5 common domains of security. These 5 domains are drawn on from our Cloud Adoption Framework, or the CAF as it's known. This provides a framework to help you structure and plan your cloud adoption journey and build a comprehensive approach to cloud computing throughout the IT lifecycle. The framework provides 7 specific areas of focus or perspectives: business, platform, maturity, people, process, operations, and finally, security. The security perspective contains 10 domains or epics, and today we will be focusing on the 5 core epics. Something I will mention again at the end is that these 5 epics are a great place to start. Make sure you do these things right. Once you feel you have a mature posture across these epics, move on to some of the others, like big data security, compliance validation, DevSecOps, and others. Before we jump into the AWS best practices, I want to quickly explore the breadth and depth of the services we have available. You can see from the slide that we have a pretty broad coverage across these common topics, but also a depth in each vertical that provides builders like you the flexibility to implement a security posture that makes sense for you and your organization. You will also notice that our services are lined up in order of the 5 core epics of the CAF. This is on purpose. All AWS security strategies should start with identity. The very first thing you do in the cloud is create a user, and that user has permission to access the environment and deploy resources. That is very different to a legacy on-premise world, where you deploy resources first and provision identity last. Diving into each AWS native service is outside the scope of this session, but I encourage you to review the list, and if there is a specific service you have not used before or want to find out more about, then look them up on the website, or even better, have a play in the web console. Okay, let's get started with best practices and our first topic, identity and access management. When you create a new AWS account, that very first user is what we call the root user. It has complete access to all the resources and services in the account and cannot be constrained by policies or permission settings. Needless to say, if this user was ever compromised by an attacker, you would have an extremely bad day. So let's focus on locking this down. The first thing you do is simply stop using this account altogether. Using IAM, create yourself a new account for administrative purposes. Going forward, use this new AWS IAM administrative account and not the root account you created during the sign-up. By not using it, you will reduce the attack surface and opportunities for attackers. Secondly, it is important to create individual users for all AWS users inside your organization. While it may be tempting to share accounts and passwords, this is bad security practice, as it does not provide traceability into actions within your account. So step 2 is to create unique IAM users for all users inside your environment. Our second best practice is nice and simple. Enable multi-factor authentication on all of your interactive web console logins. Hackers guessing passwords or malware stealing passwords via keyloggers is one of the main attack vectors facing end users, and a simple control like MFA significantly raises the bar to prevent malicious individuals accessing your account. With MFA enabled, when a user signs into AWS websites, they will be prompted for their username and password, which is the first factor, or what they know, as well as an authentication code from their MFA device, or the second factor, what they have. Taken together, these multiple factors provide increased security for your AWS account settings and resources. AWS supports a number of form factors for MFA, including virtual tokens, which can run on any application that supports the Open TOTP standard. Google Authenticator is a good example of that. We also support tamper-evident hardware-based tokens like Gemalto. Regardless of the form factor you choose, enabling MFA is a simple security control that can be enabled in minutes, and the return on investment from a security perspective is huge. Our final best practice is related to access tokens. When developers want to programmatically access AWS, they use the access tokens to sign API calls that authenticate them with the end service. This may be directly from their laptop, or they may place these access keys into code on EC2 instances to make server-level calls within the AWS ecosystem. An issue with these access keys is that they are typically long-standing. Developers create them and then do not rotate them for long periods of time, or leave them laying around where malicious users can find them. A solution to this is to use temporary access keys, known as temporary security credentials. In addition to the access keys, temporary security credentials include a security token that you must send to AWS when you use these temporary credentials. The advantage of temporary security credentials is that they are short-term. After they expire, they're no longer valid. You can use temporary access keys in less secure environments or distribute them to grant users temporary access to resources in your AWS account. So how do you get these temporary tokens? Well, if you're a developer and need the tokens on your laptop, you can use Identity Federation to assume a role inside AWS. This process of role assumption will return your local user these temporary time-bound tokens. If you need the tokens on an EC2 instance, the best practice is to pass that instance an IAM role, allowing the server to make an AWS STS call and receive temporary tokens that allow the instance to interact with other AWS services. Amazon S3 is a great example of that. Okay, that's it for identity. Let's take a look at some simple best practices for logging and monitoring that can really raise the bar. AWS CloudTrail is a service that enables governance, compliance, operational auditing, and risk auditing of your AWS account. With CloudTrail, you can log, continuously monitor, and retain account activity related to actions across your AWS infrastructure. CloudTrail provides event history of your AWS account activity, including actions taken through the AWS Management Console, AWS SDKs, command line tools, and other AWS services. This event history simplifies security analysis, resource change tracking, and troubleshooting. By default, CloudTrail is enabled for 7 days, but if you need to go back further than that, you need to explicitly create a trail. If you do ever have a security incident, your security team will thank you for having all available logs stored and ready to be reviewed. Once enabled, you will need to be able to go back in time and determine who did what from where and when inside your AWS environment. Amazon GuardDuty is a managed threat detection service that continuously monitors for malicious or unauthorized behavior to help you protect you and your AWS accounts and workloads. It monitors for activities such as unusual API calls or potentially unauthorized deployments that may indicate a possible account compromise. GuardDuty also detects potentially compromised instances or recon by attackers. Enabled with just a few clicks in the AWS Management Console, Amazon GuardDuty can immediately begin analyzing billions of events across your AWS accounts for signs of risk. GuardDuty identifies suspected attackers through integrated threat intelligence feeds and uses machine learning to detect anomalies in account and workload activity. Amazon GuardDuty is cost-effective and easy to use. It does not require you to deploy and maintain software or security infrastructure, meaning it can be enabled quickly with no risk of negatively impacting existing application workloads. There are no upfront costs with GuardDuty, no software to be deployed, and no threat intelligence feeds to manage. Customers pay for the events analyzed by GuardDuty, and there is a 30-day free trial available to every new account to the service. So turn it on today for all accounts, leave it running, and observe what findings it picks up. Even medium and low risk issues are chances to improve your security posture. The previous two best practices got you to turn on our login services. The fact that the login is occurring is half of the puzzle. You now need some method of knowing when an event occurs. As builders, you don't want to be spending your time in front of monitoring software or a graph, waiting for a security event to pop up. Instead, invest some minor upfront time to create automation that takes the security event to you wherever you are. If you can be notified automatically when a suspicious CloudTrail event occurs, or when a GuardDuty finding detects a compromised instance, you have a far greater chance of containing the threat and getting your security team involved. There are a number of ways to do this, but many customers use a combination of CloudWatch events, SNS, and Lambda to automatically take notifications from CloudWatch alarms or GuardDuty and drop them straight into messaging channels like Slack or Jira. At this point, we should have started improving our identity and login postures. And if you follow the CAF security perspective, this is the part where we start designing our infrastructure. Poor patch management is a very common reason for compromised servers or successful data breaches. It is critically important to ensure your software is fully up to date with vendor-supplied patches. AWS Systems Manager is a tool that can help with that. Systems Manager helps by maintaining security and compliance by scanning your instances against your patch, configuration, and custom policies. You can define patch baselines, maintain up-to-date antivirus definitions, and enforce firewall policies. Through these patch baselines, you can set rules to auto-approve select categories of patches to be installed, such as operating system or high-severity patches, and you can specify a list of patches that override these rules and are automatically approved or rejected if you need to. You can also schedule maintenance windows for your patches so that they are only applied during preset times. Systems Manager helps you to ensure that your software is up to date and meets your compliance policies. Hackers are constantly looking for ways to get in, and as a builder, you should be looking to reduce your attack surface as much as possible. It's also true that as builders, you now have more power than ever before. You have access to network configurations, firewall settings, and other infrastructure-related tasks that was usually part of a different team. If you want to move fast and stay secure, let's ensure a strong infrastructure security posture is in place. Firstly, Amazon Virtual Private Cloud allows you to define both public and private subnets. It can be tempting to place everything into the public subnet for ease of development, but you could be exposing yourself to unnecessary threats. Instead, place servers that do not need to be directly connected to the internet. You should place those in private subnets and let Amazon managed services like load balancers or CloudFront face off to the internet. Secondly, ensure that your security groups for both public and private subnets are appropriate. As builders, you know your application's data flow, so work with your security teams to design security groups that allow the application to function but limited unwanted network traffic. This microsegmentation will pay dividends in the ability to prevent malware attacks. Finally, think about how you plan to connect to these systems to administer them. Instead of connecting directly over the internet, use a VPN, which provides you a private connection, and use a Bastion host as your jump box, where you initially connect to and use this to pivot to other production systems. Now, I know there's a lot going on in this slide, but as builders of internet-facing applications, you are going to want to ensure that you protect yourself against distributed denial of service attacks. I am not going to go into too much detail here, as during today's conference, there is a great session titled Self-Defending Borders, where Shane spends 30 minutes diving deep on this exact topic. Be sure to check it out. I do, however, want to call out 4 specific services that you as builders should be using for all internet-facing applications. Firstly, Route 53, which is a highly available and scalable domain name service that can be used to direct traffic to your website application. It includes many advanced features like traffic flow, latency-based routing, geo-DNS, and health checks. These features allow you to control how the service responds to DNS requests in order to optimize the latency, health, and other considerations. You can use these features to improve your performance of your web application and to avoid site outages. Amazon Route 53 uses shuffle sharding and anycast stripping, so end users can access your application even if the DNS service is targeted by a DDoS attack. Amazon CloudFront is a content delivery network service that can be used to deliver your entire website, including static, dynamic, streaming, and interactive content. Persistent TCP connections and variable time to live can be used to accelerate delivery of content, even if it cannot be cached at an edge location. This allows Amazon CloudFront to protect your web application even if you are not serving static content. Amazon CloudFront only accepts well-formed connections to prevent many common DDoS attacks like SYN floods, UDP reflection attacks from reaching your origin. DDoS attacks are geographically isolated close to the source, which prevents the traffic from affecting other locations. These capabilities can greatly improve your ability to continue serving traffic to your end customers during larger DDoS attacks. You can use Amazon CloudFront to protect an origin on AWS or elsewhere on the internet. Web application firewalls are often used to protect web applications against attacks that attempt to exploit a vulnerability in the application code. Common examples include SQL injection or cross-site request forgery. You can use a web application firewall to detect and mitigate against application layer DDoS attacks. AWS WAF can protect you against these types of attacks. Finally, AWS Shield is a managed DDoS protection service that safeguards applications running on AWS. AWS Shield provides always-on detection and automatic inline mitigations that minimize application downtime and latency, so there is no need to engage AWS support to benefit from DDoS protection. Once your infrastructure is in a good place, it's time to start thinking about data protection. When we talk about encryption, it's important to make sure you protect data both in transit and at rest. For data in transit, ensure you are using TLS to prevent malicious individuals intercepting your traffic as it flows over the internet. AWS's internet-facing services, such as load balancers and CloudFront, both support TLS. From a data at rest perspective, AWS makes it extremely easy to encrypt your data across your instances, S3 storage, and many more. AWS Key Management Service is a managed service that makes it easy for you to create and control the encryption keys used to encrypt your data and uses FIPS 142 validated hardware security modules to protect the security of your keys. AWS KMS is integrated with most other AWS services to help you protect the data you store with these services. AWS KMS is also integrated with CloudTrail to provide you with logs of all key usage to help you meet your regulatory and compliance needs. Encryption is only one part of data protection. It is also critically important to ensure access is only granted to those that explicitly need it. Think about Amazon S3, our object storage service. If you stored private information there and make the bucket publicly available to anyone in the world, I think your security team is going to have some stern words with you. Remember, our goal is to continue to move fast and stay secure. So with that in mind, make sure your S3 bucket that store private and confidential data stay private. AWS IAM can be used as a preventative control to create a policy that prevents public buckets ever being created in the first place. Secondly, Amazon CloudWatch events or config rules can be used to detect in near real time when a bucket's permission have changed to public. Integrate this level of automation into the notification mechanism you made back in the login section, and you will start having visibility that allows you to react swiftly if a misconfiguration does occur. A common security issue that affects builders is when clear text credentials are laying around in source code or configuration files. Think about database credentials, server logins, or application passwords, and others. AWS Secrets Manager helps you protect the secrets needed to access your applications, your services, and IT resources. The service enables you to easily rotate, manage, and retrieve database credentials, API keys, and other secrets throughout their life cycle. Users and applications retrieve secrets with a call to Secrets Manager's APIs, eliminating the need to hard-code sensitive information in plain text. Secret Manager offers secret rotation with built-in integration for Amazon RDS, for MySQL, PostgreSQL, and Amazon Aurora. Also, the service is extensible to other types of secrets, including API keys and OAuth tokens. In addition, Secrets Manager enables you to control access to secrets using fine-grained permissions and audit secret rotation centrally for resources in the AWS Cloud, third-party services, and on-premise. The final domain is incident response and is quite often overlooked. If I asked you today, would you know with certainty if your production systems had been compromised by an attacker and they were running commands right now? The answer is quite often no. So the first best practice for incident response is to have a plan and to simply test it. You should think of incident response just like DR and penetration testing. You need to execute the test plan frequently to ensure that it works, to ensure that everybody knows what their role and responsibility is, and to identify areas of improvement. You do this when there is not a current threat, but a moment of calm. It helps you build your capability and increase your responsiveness. That way, when there is a threat, you and the wider team know all what their roles and responsibilities are, what their part to play is, you know how to engage your service providers, and you know how to bring in a specialist incident response team that you may have on standby. Some important items to include in this plan are high-level roles and responsibility, and then the technical processes to identify the threat, contain it, respond, and finally recover. When an incident occurs, you may want to roll back to clean copies of your data and systems, and to do this, you will need to have appropriate levels of backup. For EC2 instances and EBS volumes, you can use snapshots. Snapshots are incremental backups, which means that only the blocks on the device that have changed after your most recent snapshots are saved. This minimizes the time required to create the snapshot and saves on storage costs by not duplicating data. Amazon RDS creates a storage volume snapshot of your DB instance, backing up the entire database, not just individual databases. For data stored in Amazon S3, you can use versioning, and versioning is a means of keeping multiple variants of an object in the same bucket. You can use versioning to preserve, retrieve, and restore every version of every object stored in your Amazon S3 bucket. With versioning, you can easily recover from both unintended user actions and application failures. The ability to restore from snapshots and backups and versions should absolutely be part of your incident response plan. Put the process in place to perform regular snapshotting and then test the restoration as part of your simulated incident response plan. Personal Health Dashboard and Trusted Advisor are great services that can help you speed up your response time when an incident occurs. AWS Personal Health Dashboard provides alerts and remediation guidance when AWS is experiencing events that may impact you. While the Service Health Dashboard displays the general status of AWS services, Personal Health Dashboard gives you a personalized view into the performance and availability of your AWS services underlying your resources. The dashboard displays relevant and timely information to help you manage events in progress and provides proactive notification to help you plan for scheduled activities. With Personal Health Dashboard, alerts are automatically triggered by changes in the health of AWS resources, giving you event visibility and guidance to help quickly diagnose and resolve the issues. AWS Trusted Advisor is your customized cloud expert. It helps you observe best practices for the use of AWS by inspecting your environment with an eye toward saving money, improving system performance, reliability, and finally closing security gaps. As mentioned previously, it is great to use these services, but the real magic comes when you start using automation to integrate the alerts and findings into your everyday development chatter. Try integrating Trusted Advisor and Personal Health Dashboard into your Slack or DevOps channels for real-time notification when an incident or an event occurs. So in this session, we explored 15 best practices across 5 security domains. While that is a good start, that is only really scratching the surface of what can be done. After this session, I encourage you to review these 3 sources of best practice in more detail and implement them into your development plan. So hopefully that gives you some good insight into the most common best practices across a range of security domains. For those of you that are implementing all of those controls, well done. It's time to dive deeper and implement additional controls from those other sources I previously mentioned. For those of you with some gaps or just starting out, incorporate them into your development cycles and start increasing your security posture. Now to conclude, it is really important for development teams to create a security backlog. Treat the security enhancements as any other feature that you are developing. Add it to Jira or other tooling and track its progress. Start with the 5 core epics we discussed here today. We only covered 3 best practices in each of those domains, but there are many more that you can explore in our best practice documentation. Once you are done with the 5 core epics, move on to other things like big data security, compliance validation, vulnerability management, and the remaining epics. As developers, you should be taking ownership for your security. Assign a member of your team as a security champion who will drive change and keep the security requirements top of mind. Some organizations like to rotate the security champion amongst the team members to cross-train and share knowledge. Finally, try to take your security organization on this journey with you. Cloud-native applications may be very new and unfamiliar to them, so you can help them out by building some of these controls and being transparent with your security from the design phase. To gain more confidence and hands-on experience with AWS, access the digital training built by our AWS experts. Attend our instructor-led classes by qualified AWS instructors and learn how to design and deploy highly available and cost-effective architectures on AWS. Validate your technical expertise with AWS and use practice exams to help you prepare for AWS certification. AWS also has a wide partner ecosystem to help you focus on your success and take full advantage of all of the benefits that AWS has to offer. To learn more about the APN partners and find the right one that fits your needs, please visit the AWS APN booth at our showcase. Finally, I would like to thank you for attending today and sticking it out until the very end of the presentation. Enjoy the rest of the showcase.